Alright, so today we're going to look at how to use JavaScript to draw graphics and animations and things like that. And the way we do that is with a canvas. And when we start out with canvas, we create an HTML element called canvas that we set a width and a height to. And that's sort of our screen. It's our blank screen that we're going to paint on. Literally, just like a canvas that you put on an easel, grab a brush and be painting on. That's the exact same concept that we're working with JavaScript. And you'll see that a little bit more as we go through. So we have a canvas, and then in JavaScript we get that canvas, we reference it by saying get element by ID. So we have an ID of canvas, so we reference that, and then we do this. And this is something pretty standard that we do every time we're starting up a canvas in JavaScript, and that's get context 2D. And that's just sort of a default thing. And then all of the canvas methods and properties that we're going to use are going to be referenced based on that CTX, because that's our canvas object at this point. So what we're going to do is actually go through a project, and we're going to try to create something along this lines. This is a clock where you've got minutes, or seconds, minutes, and hours, and the length is determined on what portion that is. And then it's got a time and date in the middle. So we're going to see if with Canvas we can create something like that and actually make it a working clock. So the first thing that we got to do is we're going to want to create these circles, or these partial circles. And we can go in and just, for simplicity, we're going to go ahead and throw that into a function. And so we're going to say RenderTime. So this is going to be rendering a snapshot of time, and we might want to do this for our animation. We're going to want to be updating it frequently, so we're going to be able to call this function multiple times. So that's the reason we're putting it in a function. And the first thing we're going to do is we're going to actually get the date, time, hours, minutes, and seconds. And the way to do that is to use the built-in JavaScript object, the date object. So I'm going to say var now equals new date. So now I can call any of the built-in date objects off of that. And in our references, we've got from Mozilla Developer Network, we can go through and look at all the different properties and methods that are available. We can get the date, we can get day, get hours, get milliseconds, minutes. And so we're going to use a couple of those to actually get the values that we need, and then we'll start using those values in our drawing. So I'm going to say in the middle there we need today's date. So I'm going to say today equals now, and one of the methods is to DateString, and that's going to get our year, month, and day and return that as a string. Then I want to get the actual time, and that's going to be, let's just say time equals to locale string. Actually make that to locale time string. Then we want to get the hours, minutes, and seconds, so we can use those to draw our stuff out. So let's say hours equals now.get hours, var minutes equals now.get minutes, and var seconds equals now.get seconds. Now we're actually going to, later on, we're going to use milliseconds. So let's go ahead and grab those while we're at it. And we'll look at later what we can do with them. Okay, milliseconds. So these are a snapshot. When it gets the new date, it grabs a snapshot of the time when that line actually ran. And then all these are just pulling information about that date out into separate variables. Okay. So in our graphic, in our canvas, we're going to want to draw several things. And I'm just going to go ahead and mark these out so we can go through them. We're going to want to draw a background. We're going to want to draw the hours. We're going to want to draw the minutes and the seconds, and the date, that text string, and the time. So those are our goals. We want to draw each one of these out there. We're going to start with minutes. Now, Canvas does not have just a straight method where it says draw circle, okay? But it does have an arc method. And that arc method is just arc. And it has a couple of arguments that it's expecting. First, it needs to know where on the canvas we want to draw it. Okay, so we've got our canvas. We don't actually see it over here because we haven't drawn anything on it yet. But we say it's a 500 pixels. And we plot where stuff is going to be drawn on it by using a grid system. And the top left corner is 0, 0. And we can, just like on a regular grid, we can move over X number of pixels. We can move down Y number of pixels. And so we can kind of plot where we want stuff to be by using the XY coordinate system. So the first two arguments in our arc method is where we want the center of the circle to be. So if we want this to be dead center, then we're going to say 250 pixels, because that's moving over halfway into our 500 pixel block. Then we'll move halfway down to get to the center. So Y is also going to be 250 pixels. And these are just needing numbers, not actual measurements. And then the next one is it needs a radius. So let's say that we want to use 200 as our radius. And then it needs to know where we want to start drawing this arc. Okay, now we want to, if we want to draw a full circle, then we could say we want to start at 0 and we want to go around so many units. So the interesting thing, the reason I say units is because this is not measuring like we normally would. It's not measuring with degrees. It's using a measurement called radians. And radians are a little bit more of an interesting way to measure angles. Not quite as popular, but let's take a second and look at what radians are, and then we're going to create a function that will convert from degrees into radians so we can use degrees and not have to run the calculation each and every time we want to figure something out. So let's jump over here to Photoshop where we can actually draw some stuff out. So if we have, let's try to understand what a radian measurement is in the first place. So let's say we've got a circle here, nice perfect circle like that. And we know that the circumference of the circle is measured by the formula pi d, which is the parameter, the diameter times 3.1415, that number, pi. And so that means the diameter of the circle, this going all the way across, is going to wrap around the edge of the circle 3.1415 times. Okay, and that means the radius is going to, we could express it the same way by saying pi to r. And so that just means that the radius, this particular measurement, would wrap around the circle 6.28 something times. Okay, and the reason I say that is because the one radian, one measurement of radian, is equal on the outer edge to one radius. If we were to take this line here and wrap it along the edge, it's going to be as long as 1 radian. So the total number of radians is going to be 6.28 and on, or it's actually going to be pi times 2. So if we're wanting to make this conversion, we're going to say that 360 degrees is equal to pi times 2. Okay, so we know that we could simplify this using basic algebra and divide by 2, which would give us, moving down over here, 180 degrees equals pi. But I want to know what is 1 degree, and what's the factor that we would convert 1 degree into a radian. So if we wanted to get 1 degree, we'd divide this by 180 degrees, as well as this side, 180 degrees, and that's going to say 1 degree is equal to the value of pi divided by 180. Okay, so we can use that That's our factor for converting from degrees into radians. And we're going to use that in our function to make that conversion. So now you understand a little bit about radians and how we can use them, what they are, and how to convert. So let's jump back into the code. And let's create a function here. So we could say function degree to rad, keep it short and simple. And we need to pass in the degrees that we want to convert. So let's just say our argument is degree. And then we're going to create our factor. And that's going to be equal to pi, which we can get the value of pi off of the math object in JavaScript, which is built in. And so we say math.pi divided by 180. And so that's our factor. So then what we actually want this function to return is degree times the factor. And that's going to return the number of radians in that degrees. So if we pass 360, the value is going to be 6.28 or something like that. So now when we come down here, we could say, okay, if we want to start at 0, well, we already did that, and that's okay. And then our next value, we want it to, let's say we want it to move around 180 degrees. So we would come in and say degree to rad 180. Now remember that we said if we use a function in as an argument and we include the parentheses, that means it's going to execute, and the argument becomes not the function but the result of the function, which is exactly what we want in this case. We want the result of that degree to rad function, not the function itself. It's a small distinction, but for our case it's absolutely perfect for what we're looking for. So that's the very basics of doing an arc. But before we can actually draw it on there, we need to say begin path. Okay, that says, okay, we're ready to draw something. And then once we're done creating our arc, then we actually use the stroke method to actually write it out. Okay, so let's come down here and actually execute the RenderTime function and see if it writes anything out for us. Okay, so we see we actually do have it written, but it started over here. We said we want to start at the 0 radian and move 180 degrees, so we saw it moved 180 degrees, but you'll notice that it starts over here. Now normally we would think we'd start at the top of the circle and move down, but this is 0.0. So for our clock, we wanted to start at the top and move down. We would need to move back 90 degrees or move forward. So in this case, we could come in and say degree to rad, in this case we'll say 270 degrees, which is going to be from here. This is 180, add 90, gets us to the top. So we're going to say start right up here, so degree to rad 270, and then run 180 degrees around. Okay, and so it did exactly what we're looking for, but we actually want it to actually run 180 degrees, so we might come in and say 180 minus 90. So now we see it's drawing our 180 degrees like we would expect, because we've taken both of these values and accounted for the fact that we're trying to start at the top, not at the default position over on the middle of the right hand side. Okay, so this isn't actually drawing an hour. We just used 180 as an example, but we want it to draw the number of hours. Okay, so I could just come in here and say hours, but that's not an actual degree number. That is just what the actual time is. So right now would be 23, because this is on a 24-hour cycle. So we're saying this is 23 minus 90. That's not what we're looking for. We actually need to see how many degrees out of 360 we want this to move per hour. Okay, so if we got 24 hours and we've got 360 degrees, then every hour is going to be equivalent to 15 degrees. So we say for every hour we want to move 15 degrees more. And so we can say times 15. We'll need to put this in parentheses since we're going to subtract right after that. And now we should have an arc that's going to go from the top all the way to whatever it needs to based on the current time. Which in this case you can see if it's 11 o'clock at night, then we're almost through our 24-hour cycle, and it's drawing it just like we'd expect. It's not styled like we want, but that's okay. So I'm going to duplicate this because we're going to use very similar for minutes. We want a slightly smaller circle, so we're going to take the radius down to 170, so it's going to be a concentric circle inside here. We're still going to start at the top, so we start at 270. We're going to change this to minutes. So now instead of 24 hours, we've got 60 minutes, and so we need to change this from 15 to 6, because 60 or 360 divided by 60 equals 6. So now we're saying for every minute of time that's elapsed, we want it to add 6 degrees to the length of our circle. So let's run this, see if it works. Perfect, we've got this running around a little more than halfway, which according to the time of 38, that should be about right. So let's do this one more time for seconds. Okay, and seconds, there's 60 seconds in a minute, so we can use the same factor of 6. And we're just changing the variable out to use seconds. And we want to make this a little bit smaller, so we decreased it by 30 last time, we'll decrease it by 30 again. Now if we run it, we've got just like we'd expect. And of course, as we update this, we're going to see every second that it increases. But we've got to do this every time, and that's going to get annoying. So we actually want to automate that. So we can come in and use a function that we talked about much earlier in class, and that's called set interval. And that sets a timer. And if you remember that the set interval takes 2 arguments, the first one is a function that we want to run, which in this case is RenderTime. And the second is how many milliseconds we want to run, or in between each time that function gets run. So since we're using milliseconds, let's say that we want it to run like a video you'd see in a movie theater at 25 frames per second. So if we said 1,000 divided by 25, that gives us, we want this thing to update every 40 milliseconds. Okay, so let's run this. Now you're seeing that it's updating, and it's jumping. Every second, it's jumping. So that gets us a fair amount of the way there. But we kind of want to, I'd like this to smooth out. I don't want it to jump every so often. We're updating every 40 milliseconds. We could get this to update incrementally and have a nice smooth fade through here. So in order to do that, we're going to use our get milliseconds that we created earlier. And I'm going to create a new variable here called new seconds. Okay, and so this is going to be a more accurate. So we're going to have seconds plus a fraction of a second using the get milliseconds. And we do that by saying seconds plus, let's create a parentheses there since we're going to do some math in there. And we say now, or we'll just say milliseconds divided by 1,000. So what this is telling us is that since we have 1,000 milliseconds in a second, we're dividing it by 1,000 so that we get a number that is a percentage, or a basically a percentage of a second. So it's going to be basically a whole lot more. It's going to be accurate to the millisecond, and then all we have to do is come in and replace this variable down here with the new one we created. And now when we watch it, instead of it jumping, we should see it actually very smoothly coming through here. Now we see a problem because we said that we're painting onto this object. Okay, so as it paints, nothing we're basically redrawing it each time, but we're drawing it over the existing pixels that we had painted before. So as I come over here, when I hit up here, it's still moving. We just don't see it. okay, because it's still tracing over what we've already done. So if we want to see it refresh and not just draw over itself, then we need to have a background. And so we're going to write a background first, then write our 3 arcs on top of it. And if we do that every 40 milliseconds, then we're going to basically be rewriting every pixel on the screen. And so we're not going to have this overwriting like we do right now. So let's go ahead and do that. It should make a little more sense once we go there. The first thing we want to do is go ahead and say fill style, and this is setting the color of the fill that we're going to use. And we're just going to say 333, which is the hex code for a very dark gray. You can use just about any sort of CSS color here. I could, since black is predefined in CSS, I could say black. We're just going to say 333 right here. So that's saying here's a color we're going to use when we fill a block. And then let's actually create our block. And we do that with a method called fill rectangle, or fill rect. And in this, we're going to have 4 arguments. We're going to have the x and y coordinates of the top left-hand corner, which is our starting point. And then we're going to come down and specify the coordinates of our bottom right-hand corner. And by defining those 2 coordinates, we'll define a rectangle and actually filled it. So if we came in here, we say we want to cover the entire canvas, which is 500 pixels by 500 pixels. So let's say that our first coordinates are 0, 0, which is top left, and then our bottom coordinates are 500 and 500. So that's going to cover our entire canvas. So if we run that, we see that's working as we'd expect. And as we'll see here in a second, when it comes back up to here, it's not going to keep overriding. It's actually going to refresh this, because this entire canvas is being rewritten, every pixel of it, every 25th of a second. So this is, kind of hard to see. We can barely see our lines here. So what if we go in and actually define some default styles? We could come in and say ctx dot stroke style equals, and this is a color I looked up ahead of time, D1 28 D1 FA, and that's just a hex code for light blue. I want to set the width of it, and these are set defaults. We can, as you can see, this just jumped over here and refreshed, not overriding. So let's go back. We were talking about line width. We can set this, and it just needs a number, so we can say what a line width of 17. So if I change this, all of a sudden we get much closer to what our goal is. If you remember, our goal is something like this. And we can also say, okay, these are straight edges, but maybe I want them rounded. And if we look at our cheat sheet, it actually tells us that we can use an attribute or a property called line cap that expects a string of one of the following values, but round or square. So if we want round, we could come in and say ctx dot line cap equals round. So now we've got something like that. And you also see that in our example, there's a little bit of a glow around it. Kind of gives it a digital glowing feel to it. And we can duplicate that with a shadow. And instead of just doing a shadow, we're going to set the color of that shadow to the same color as our line. So it's just going to look like it has a glow to it, not a shadow. So I can say ctx dot shadow blur equals 15. That's how many pixels I want it to blur. And then I'm going to set the color of it with the property of shadow color equal to the same as up there, which is 28 D1 FA. And now if we run it, we see it's got a little bit of a glow to it. So we're making progress at this point. So let's go down here and look and see what we're missing. We want to put the date and time in there. And that is done by creating a font style, and then filling some text in on there, on our canvas. Okay, and we can see in our cheat sheet here that we've got font, and we've got stuff like fill text. So let's use those. We're going to let's set the font style first. We're going to come in and say ctx.font. And this is going to be very similar to a CSS string. So I'm going to say 25 pixels, use the Arial font. And then I'm going to say ctx.fill style equals, I want to use the same color as the line, so I'm going to use that same 28 D1FA, and so that's going to be the color of my font. Now we're changing fill style because we originally set fill style up here to gray for the background, so we're just changing that down here. Each time that this runs, it's going to get set here and then reset down here, and that's what we're looking for. Okay, so the next thing we want to do is use the fill text method, and we need to pass some information in here. So we've got a date string as a variable called today, and the first argument in the fill text is the text that we actually want to use to display on there. So we can just use that. I'll say today. Then the next two arguments that it's expecting is the coordinates of where we want this text to show up. And so we're going to say that we want it to be at 175 X and about 250 for Y. So if we look at it, it shows up in there, fits within our circle, and we basically just set it to show up a little bit before. 175 means it's not starting here, it's actually starting over, but it's still fairly centered as far as the Y coordinate goes. So that fits inside, has our date just like we'd hope. Now we need to come in and add a very similar thing. So we'll just copy this as our starting place. We need to add in the time. So we go back up here and look, we have toLocaleTimeString as a variable called time. So let's go down here and say time, and we don't want it on the same place as here, so let's just change this to be a little bit lower, so it would be the same x width, but the Y value is a little bit greater, so it's going to be below it. And let's make this 15 pixels. We could also, if we want to separate these out, I could come up here and say bold on this one, and that's going to apply bold. So you see that this is bold, this is a little bit smaller, showing up right below it. So that's looking good for us. Now what if we want to, let's demonstrate what we can do on the background. Okay, it's a fairly simple background, but we kind of want to create a radial gradient. So we want it to be a little bit lighter in the middle and kind of darken as it gets out toward the edge. So it kind of looks like our three rings here are actually lighting it up. So we can do that by using a method called createRadialGradient. And I'm going to go ahead and start that here. So let's create a variable called gradient equals ctx.createRadialGradient. Okay. Now this method expects 6 arguments, and it's a little bit confusing at first, but it's a little bit simpler once you get used to it. It's expecting us to define 2 circles because we said it's a radial gradient. And the first circle is, these are going to be concentric for what we're doing right here. But the first circle is saying, okay, we want it to start at a certain point and go out. So if I said, okay, I've got a circle that just has a very small radius right here, that's going to be where I want my first color to show up. And I want to change to another color out here. So I'd say, okay, I've got our outer circle is here on the edge, and that's where we want our color to stop changing. Okay, so now we haven't defined our colors yet, but we will in just a second. So let's create a very small circle first. We want it to be in the middle of the screen, so we can say 250 and 250. And let's do a radius of 5 on that inner circle. And then on our outer one, we use the same coordinates because these are concentric circles. So we say the center of this one is the same, which is 250 and 250, but we want to do maybe 300 as the radius of our outer circle. So we're going to have a gradient that's 295 pixels, and it's going to start in here and change color all the way out. So in order to do that, we add what's called color stops. So we say gradient dot add color stop, and it expects that the first argument is going to be which color we're looking for. So we said we have an inner circle and an outer circle that define the bounds of this gradient. So the inner one is considered 0 and the outer one is considered 1. So I can say the first one is I want at that where it starts, let's make the color, and I'm just going to pick a previous color that we set here, 09303A. Just happens to be a color I thought would look good. And then I want it to change to, by the time it gets to that outer circle, which is considered 1, I want it to change to just black. And then I'm going to comment this out. Instead of using a color, I could come in and say CTX fill style and pass in the gradient variable that I've been adding all this stuff to. So I'm saying in the very center, use this color and change it out to black as it gets closer to the outer circle. And then we're going to say use that as our background color, or in place of the color. So if I run this, you can see it does exactly what we'd hope. We've got a dark blue in here that fades out to black as it gets out to that 300 pixel radius. So it sort of gives it like we've created a little glow effect inside. So that's all we're going to look at as far as Canvas goes, as far as drawing things. There's a world of possibilities inside Canvas as far as what you can draw. There's a lot of extra libraries built around Canvas that you can use to create 3D objects, animations, all sorts of stuff. You know, we've looked at some of the lower level, you know, drawing lines and arcs and rectangles and stuff, but there's so much more that you can do with it. And a lot of these libraries, just like jQuery abstracts away selecting elements in the DOM, there's a lot of libraries that abstract away doing simple things inside of Canvas. So I recommend, if you're going to use it very much, find some libraries that you like and go with those. So before we finish, I'm going to talk about how we can assign this to an image. Okay, because right now if I right click it, I can't save it, I can't do anything with it. I'm just it's just a sort of an odd canvas. It doesn't really have a place with us right now. So if I wanted to, I could assign this to an image tag. So I'm going to say image. Let's give it an ID of my image. And then we could come in here and say, we can call this data URL, and we'll look at what that is in a second. But I'm going to basically select it. Actually, I'm getting ahead of myself. Let's close that off for a second. So I'm going to want to take the value of this data URL, which we're going to set in a second, and assign it to that image, which we can do using, as we've done many times, get element by ID, and of course we're looking for my image, and I want to set the source of that. So I can just say source equals whatever we put into that data URL variable. So this is just going to use a built-in Canvas method called toDataURL. So let's go ahead and do that. Canvas toDataURL. This is a method. So what is it actually doing here? A data URL is sort of a unique concept within HTML and browsers. Normally, we'd come in and actually assign a path of where this image resource is located, right? We'd use a source attribute to say it's located on this particular place on our server. and the browser is going to download the HTML, then it's going to go download those images, and it's going to download our style sheets and JavaScript files and all that stuff. But with a data URL, it's a way of encoding the binary information of an image and converting it into text basically, and then having it where the browser can interpret that if that text was actually embedded in our HTML. And it's very rarely used, but it does have some advantages which we'll look at in a second. But just know that right now we're saying, okay, take all of the information about that canvas image and save it to a data URL, so that when we assign it to the source, we're actually going to assign that canvas image to this image tag. And that's going to give us some unique things that we can do. If we look at it, we're going to see it actually, now we've got two. One is the canvas and one is the image tag. And the difference is I can click on this one and actually do save image as, go to the image, copy it, things like that. So we could come in here and hide our original canvas if we wanted to, so that people would only see the image. I can say display none. Now when I run it, I've only got that one image. Now this isn't terribly useful for us at this point. It does allow people to save it and take a snapshot, but it also means, since we've got all the information about this canvas rendered into one very, very long text string, then we can, let's see if we can actually look at that. I'm not sure if it's going to let me do it. Let's see. I don't believe it is. So it's actually much longer. This is abbreviated, but you'll get a very, very, very long string of text that's preprinted with this data, image, PNG, base64, and it's telling the browser, okay, everything after this point should be decoded with base64. It's a PNG type thing, and so it's telling the browser how to render it and how to interpret all that text that follows. And so the browser is going to take all that and run some functions on it and convert it into what we understand as an image. So it doesn't really show us a great, you can see it's actually a much longer string up here in the top. You can see a little bit more of. But the advantage is that we can send this string to the server, and if we want to use Ajax and some sort of server-side programming, we could render, save this to the server in a file somewhere, and so we can take snapshots of it, things like that. So there's lots of potential there. So that's all for today. I believe that should cover just about everything, and we'll come back next time.